Hello students, today we will be dealing with the last part of concentration terms. Till the time we have seen that what do we mean by percentage composition, molality, normality. Now some more concentration terms are left that we are going to discuss here. So the very first out of these left concentration terms that I am going to take today is parts per million. This parts per million is also indicated by the symbol ppm. So this indicates parts per million. This is the short abbreviation we use for this parts per million. Basically, this parts per million is defined as the amount of solute present in 10 to the power 6 gram, 10 to the power 6 part of the solution. So it's the mass of solute present in 10 to the power 6 gram of solution. Hello students, till the last time we have dealt with some types of concentration terms, like last time we have dealt with percentage composition, molality and normality. Now we are going to start with the left part of these concentration terms, and today's very first concentration term that we will be discussing is parts per million. This parts per million, in short, it is indicated by the abbreviation ppm. And basically, this parts per million is defined as the mass of solute present in 10 to the power 6 gram of solution. So, from the definition, we can give the formula for this parts per million. This ppm parts per million is equals to the mass of solute divided with mass of solution and multiplied with 10 to the power 6, that is 1 million. So by putting the value of all the required things here, the concentration term that we will be getting is parts per million. Now move for a question based on this problem. Like here a question is provided to us. So here the question is given to us as 2.5 gram of a sample of groundwater that is working like a solution here. It contains 5.4 milligram of zinc plus 2 iron, and we are to calculate the concentration of zinc cation in parts per million. As we know that this parts per million is equals to the mass of solute that is given as 5.4 microgram, and since here in this formula we put the concentration in gram, so for the conversion of this 5.4 microgram we will multiply this 5.4 into 10 to the power minus with 10 to the power minus 6 to convert this into gram, divided with the mass of solution, and the mass of solution is given as 2.5 gram. Since we are talking about the parts per million, so we need to multiply this with 10 to the power 6. This 10 raised to the power 6 will be cancelled with this 10 raised to the power 6. Resultant here the concentration in parts per million will be equals to 5.4 divided with 2.5, and on solving this we will be getting the value as 2.16. So that is the concentration of zinc cation in parts per million. Now other than this parts per million, some more concentration terms are used, like the next one is formality. Basically, this formality is similar to the molality, only one difference is there between the molality and formality. Molality concentration term is generally used for the covalent compounds, while this formality is used to represent the concentration of ionic compounds. As we know that for the ionic compounds, instead of writing the smallest unit as molecule, we indicate the smallest unit by the term formula unit. So when we take the formality, which is indicated by the symbol capital F, it will be equals to the mass of any substance divided with, instead of molecular mass, here we will be talking about the formula mass of that substance. This formula mass indicates the mass of that formula unit, that is the smallest unit of that ionic compound. And when this formula mass is multiplied with the volume of solution that we take in liter. So by putting the value of all the things, that is the mass of solute divided with formula mass and volume of solution, the concentration we will be getting in the form of formality. And here only one difference is, as we have seen in the case of molarity, this molarity is equals to the mass of solute divided with gram molecular mass and the volume of solution. So here we can see that this mass of solute divided with the volume of solution is same in these two kinds of concentration term. Only the difference is, here we talk about the gram formula mass, while in case of molarity we take gram molecular mass, that is the mass of molecule, and this gram formula mass is the mass of formula unit, that is the smallest unit of ionic compound. So when we talk about the ionic compound, instead of writing the molarity of the solution, we prefer to write the concentration in formality. Now we will move to the next kind of concentration term, that is mole fraction. This mole fraction is indicated by the symbol X. And this mole fraction, as the name is indicating, it indicates, or it is the ratio of total number of moles of a particular component to the total number of moles of the solution. Now from the definition we can write the formula for this mole fraction. This mole fraction, if we are having a solution made by two components, that is A and B, and here this A is working like a solute where this B is working like a solvent. So by the addition of these two we will be getting the solution here. And when we are talking about the mole fraction of the component A here, that is solute here, so that will be equals to moles of A divided with the total moles, that is equals to moles of A plus moles of B. And by this, by taking the ratio of this moles of A to the total moles, we will be getting the mole fraction for this A. On the other hand, when we talk about the mole fraction for the component B, this mole fraction of B will be equals to moles of B divided with the total moles, that is moles of A plus moles of B. So that is about the mole fraction, and this is here we have complete all the kinds of concentration terms.